Okay, so as you see, this is, as promised, part 2 of my series on trigonometric integrals. And how I'm defining that for right now is integrals of the form like this. So mixed powers of sine and or cosine, all right? In the video I already made, part 1, I talked about case 1 of this type of problem. And now it's time to talk about case 2, all right? So I thought I would start with this, and again, this is something you should know how to do already, but I'm putting it here because I want to compare with this new problem. Because when we learn all these techniques of integration, which is just how it goes in calculus 2, I mean, there's no way around it. That's what calculus 2 is. But when we learn all these techniques of integration, we have to get a feel for telling them all apart, right? Like a certain problem you use U-Substitution for, another problem maybe you use integration by parts, and so on. You'll learn more techniques and you have to differentiate them. So with this one, I hope we can tell that that's just like straightforward, basic, easy U-Substitution. If you let U be cosine, then du pretty easily works out to be negative sine, right? And then that substitution will work so long as we deal with this negative here. So let's say negative du is going to be sine theta d theta. All right, so that's what we wanted, and that will work up here, and it's not really a difficult problem. All right, so I'll substitute u. I'll substitute for sine theta d theta. I'll substitute negative du, and I'll get this u squared. All right, cosine squared. U is cosine. That will become u squared. Sine theta d theta will be negative 1 times du. Of course, that's not a subtraction. That's a factor of negative 1. So we'll bring that negative 1 out here as we do with constants like that in integrals. We'll get this. And then we ought to know the answer at that point. Negative u to the third power over 3 plus c, which that translates to cosine to the third power. Negative cosine to the third power theta over 3 plus c, right? Okay. All right. We should know how to do that, as I already said. But can we tell this problem apart from this one? They look similar. I intend them to look similar. That's the whole idea. But this one is missing the sign, right? And so this one is not, in its given form, going to be a U-substitution problem. It just isn't, all right? Okay, if it had sign there, then no matter what that power is, it would be something like this. Okay, so we're going to have to figure out some other way to do this one. But before we figure that out, we can at least agree it's not like that. Okay? All right. So here goes. Let's talk about what would be case 2. So say you have some problem with mixed powers of sine and or cosine. All right? What if the powers are all even? All right? Now I know I said that they're both even. And I know I wrote it like that. I'm not saying these problems have to have both sine and cosine. It's mixed powers of sine and or cosine. But say the powers are all even, then you can reduce the integral with these identities. Okay? Like this one says cosine squared of an angle is 1 plus cosine of twice the angle over 2. All right? That's what we want for this problem. Okay? All right. So here goes. Let's use that identity. It said that cosine squared of an angle is 1 plus cosine of 2 times the angle over 2. So this will be 1 plus cosine squared, cosine of 2 theta, all divided by 2, right? That's what it said, all over 2. Like that. Okay, so that's just an identity. Now, I would like to go ahead and make a note about that. So it's like right here, there's an identity. And this is probably how you see it like in a pre-calculus book or something like that. Cosine squared of x is 1 plus cosine 2x over 2. Maybe you've seen it before, but it's what we want right here. Okay. All right. Now, from this point, what I want to do is separate this fraction out. Like I could see this fraction as a 1/2, okay, plus cosine 2 theta over 2. And I can see it like that because I could add these back together, seeing that they have a common denominator of 2, and combine them into that, so I can take it back apart. Okay. Now, for these are each easily doable. This one, well, that's just a constant. What's the antiderivative of 1/2 d theta? That will be, let's say, 1/2 theta. And what's the antiderivative of cosine 2 theta over 2? Well, it turns out that part of it, like right here, the cosine 2 theta over 2, that's U-substitution. Okay? Now, for now, I'd like to just tell you the answer. You're going to get 1/4 sine 2 theta. And I tend to do things like that in my head because I realize it's kind of like the chain rule. Like, what's the derivative of sine 2 theta? It's cosine 2 theta times 2. And then the 2 cancels with the 4 and gets me 1/2. That's how I do it. But most people probably see it as U-substitution. All right? Okay. So there's my answer. Now, I would like to put a note about that. All right? I didn't want to do the U-substitution right here just to clutter up the problem. So let me put that as a note, how I did that. Okay? All right, note. Suppose you were dealing with just this. Because I think there is no controversy about the 1/2. Okay? So let's say cosine 2 theta over 2. How am I seeing that to be U-substitution? Well, the form that I see that this is going to take is cosine of u du. That's what kind of U-substitution I see that this is going to be. So I'll let u be 2 theta. As a result of that, du will be 2 d theta. And in order to make my substitutions work, I'll solve and get that du over 2 will be d theta, right? So everything fits. I've got a place for this. I can substitute theta out in terms of u. And I've got a place for this. I can substitute d theta out in terms of du. All right, and that's how U-substitution works, right? So, all right, in this step right here, between these two substitutions, I'll get this. Cosine of u, all right, and I still have this constant of 2. D theta will be du over 2. Okay? Now, between those 2's, I'm looking at a factor of 1/4, which I'll remove. And I'll be left with this. Okay, and so remember, in the beginning I said I think the form that this one's going to take is cosine of u du, and sure enough it does. All right. So my answer then, antiderivative of cosine is sine, so I'll get sine u plus c, and given that u was 2 theta, then I'll say my final answer is 1/4 sine 2 theta plus c. All right. And then so I'm done with that one, but that's this part of it, okay? I was just doing that in my head, and if you can do it in your head, great. You know, if you like to be a little more thorough and write things out, then that's how it's going to look if you use U-substitution. Okay. So let's do one more that deals with the even powers of sine and or cosine and using these types of identities, okay? Because remember, this case 2, mixed powers of sine and or cosine, where the powers are all even, then we use these identities as needed, okay? All right, so let's see another one. Just to round this out, what about this one? Sine squared 3 theta, cosine squared 3 theta. Is that a U-substitution problem, say like this one? I don't see how it can be, because if you need, like for sine, if you were going to let that be U, d would be cosine. I've got cosine squared. And if I was going to say let cosine be U, d would be sine, and I've got sine squared. I don't think there's any way around that. So it's not, at least here, it's not a U-substitution problem. But I have my cases, right? And if we have all even powers, we use the identities. Cosine squared of an angle is 1 plus cosine of twice the angle over 2. And sine squared of an angle is 1 minus cosine of twice the angle over 2. That's what we want here. Okay? So, okay, that will be the procedure when we have all even powers of sine and or cosine. So, with this first one, so what did it say? It says sine squared of an angle is 1 minus cosine of twice the angle over 2. All right, that was that identity I just showed you. Given that the angle there is actually 3 theta, I need that to be 6 theta. And over here, cosine squared of 3 theta, well, cosine squared of an angle is 1 plus cosine of twice the angle. All right, so that would be 6 theta over 2. All right, so now we're looking at this. And if we sort this out, then I think you'll see that we get something we know how to do, and it will be, once again, it'll be U-substitution. All right? So how about this? If I multiply these fractions together, here's what I'll get. Of course, we multiply a fraction straight across. And 1 minus cosine 6 theta times 1 plus cosine 6 theta. That will be FOIL multiplication. All right? And we'll get 1 times 1. Then we'll get cosine 6 theta and then minus cosine 6 theta. So those will cancel. And then we'll get negative cosine squared of 6 theta over 2. All right. Cosine 6 theta times cosine 6 theta. Now, let's do this. Oh, sorry, that's not over 2, that's over 4. 2 times 2 is 4. All right. So next, let's do this. I have a 4 right there. That's a 1/4. That's a factor of 1/4. It's like we're looking at 1/4 times 1 minus cosine squared of 6 theta. Okay, so I'm going to take that 1/4 and put it out there. Now, what do we do? Like, can we integrate 1? Yes, that's a constant. That's not hard to do. What about cosine squared of 6 theta? Can we integrate that? Well, for that one, I think we're back to this. It's even, right? And so I'm still looking at the integral of an even power of cosine. What do we do with even powers of sine or cosine? We use these identities. So I need to use that identity again. All right? So, okay, so for that part right there, I'm going to use the identity that I used up here again. All right? Okay, that's how we're going to handle even powers of sine and or cosine. So I'll leave this one alone. What about this cosine squared 6 theta? What was that identity? Cosine squared of an angle. It says cosine squared of an angle is 1 plus cosine of double the angle over 2. So in my case, this will be 1 plus cosine of 12 theta over 2. Okay, so that's how it's going to work out. Now I think we're to the point where it's going to be just U-substitution. But let's do this. So I have this 1 here, uncontroversial. I have this minus, all right? And then for the rest of it, I'll split this apart. I did that in a problem just a minute ago. This is 1/2 plus cosine 12 theta over 2. But I'm subtracting this entire expression if it has multiple terms in it. So I'm going to say 1/2 minus cosine 12 theta over 2. Okay. So there we go. I split this up into two terms and realize this subtraction applies to both of them. So it's going to look like that. And almost there, almost. 1 minus 1/2 is 1/2. And then we'll just leave this. Okay. Now, that's not hard. 1/2 is a constant. And then this thing right here, that's like something that we saw just a minute ago. This is U-Substitution. Okay? Let the U be 12 theta. And it will work out for you. All right? Okay. So I think that's something that you can handle. So I'm going to leave that up to you. Because it's just like one I showed you a second ago. So I'll get this. 1/4 times, all right, what's the antiderivative of 1/2 minus cosine 12 theta over 2? That'll be 1/2 theta minus, and for this one, you'll get sine 12 theta over 24. And then plus c. Okay? All right, that's what your U-substitution is going to give you there. All right, so my final answer, let's do this. Might as well multiply the 1/4 in there that's been sitting here the whole time. We'll get 1/8 theta, okay, minus, so I've got that 24 and a 4, so we'll say 1/96 sine 12 theta and plus c. All right. So that's how we handle even powers of sine and or cosine. And in one problem, we may have to use those identities for even powers 1 time, 2 times, 3 times, right? But that's what we do when we see an even power of sine and or cosine. All right. So now I've covered both of my cases, but this being my second video in the series for integrals of this form. If either one of the powers is odd, then that was addressed in my first video, okay? And if all the powers are even, well, that's what you just saw. And that's both cases of this integral right here.